welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're going to start with your chemistry for class 11, that is your class 15. We had done your class 14 in the last classes, and where we had completed unit 8, which is the redox reaction, and now we'll continue with unit 9, which is your hydrogen. In terms of hydrogen, we talk about it. This is which we had completed many of the topic related to it, and we'll be surely ending it up in this class if it has not been exceeded. So before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and even you can also enjoy the video as well. So here we go for it. Lastly, we had done for the D2O and many of the equations related to it, dihydrogen conversion as well. Today we'll discuss about the structures. So in terms of structure here, the hydrogen peroxide has a non-planar structure, and that is the molecular dimensions in the given phases and the solid phases. We'll discuss that. So the gas phase, and of course for the solid phase we'll discuss. So for the gas phase, this is for the gas phase. So here this is your hydrogen. This is 95.0 pm. This is 147.5 pm. So for this it will be the hydrogen here. It is 94.8 degree, and this is 111.5. So here this is for the gas phase, okay. And now we talk for the solids phase. This is here, it is 98.8 pm, and this is 145.8 pm. The angle here, this is oxygen, hydrogen, this is the angle, it will be 101.9, and this is your 90.2. This is for solid phase. Here for this, here in H2O2, that is your the structure in the gas phase, which is dihedral angle is 111.5, and where H2O2 structure in solid phase, that is at 110 Kelvin, the dihedral angle is your 90.2. Bear in that here you can see this is the inside angle is your 94.8, and this is your 101.9 here 9 here. So this is the differences between the gas phase and solid phase of a same H2O2 molecule. And now we talk about for the another one, which is for the chemical properties, and that has been the important one as well. So here we go. In terms of chemical properties, it acts as an oxidizing as well as reducing in both acidic and alkaline media. The simple reactions are described here. So for the first one is that oxidizing actions in acidic medium. So it will be 2Fe 2 plus aqueous plus 2H plus aqueous plus H2O2 aqueous will give 2Fe 3 plus aqueous plus 2H2O liquid. Yeah, PBS solid plus 4H2O2 aqueous will give PbSO4 solid plus 4H2O liquid. Now we talk for the another one, which has been the another important question here, and that is your reducing action in acidic medium. So it will be 2MnO4 minus plus 6H plus 5H2O2 will give 2Mn2 plus 8H2O plus 5O2. Another one, HOCl plus H2O2 will give MnO4 plus 2OH minus. By reducing the actions in the basic medium, it will be I2 plus H2O2 plus 2OH minus will give 2I minus plus 2H2O plus O2. 2MnO4 minus plus 3H2O2 will give 2MnO2 plus 3O2 plus 2H2O plus 2OH minus. Now we talk about for the another one, which we'll be talking here, and that is for the another one, that is for storage. In terms of storage, H2O2 decomposes slowly on exposures to light, and so here 2H2O2 liquid will give 2H2O liquid plus O2, which is in the form of gas here. So in the presence of metal surfaces or the traces of alkali which is present in the gas container, so the above reaction is catalyzed and it is therefore stored in the wax lined glass or plastic vessels. In dark, urea can be added as a stabilizer. It is kept away from dust because dust can induce explosive decompositions of the compound. Now we talk about for here in terms of storage, that is the uses, of course. The another one, so in terms of uses, it is a wide scale that has led to the tremendous increase in the industrial productions of H2O2, where some of the uses were listed here, and we'll discuss that. In daily life, it is used as a hair bleach and as a mild disinfectant, as an antiseptic. It is sold in the market as a perhydrol. It is used to manufacture chemicals like sodium perborate and percarborate, which are used in high quality detergent. It is used in the synthesis of hydroquinone, that is tartaric acid, and certain food products and pharmaceuticals, which is your cephalosporin and cephalosporin, etc. It is employed in the industries as a bleaching agent for textiles, paper, pulp, leather, oils, fats, etc. Nowadays, it is also used in environmental, which is green chemistry. For example, in pollution control, treatment of domestic and industrial effluents, that oxidations of cyanides, restorations of that is aerobic conditions to sewage wastes, etc. Now we talk about for the heavy water, which is your D2O. So in terms of D2O here, it is extensively used as a moderator in nuclear reactor and in exchange reactions for the study of reaction mechanism. It can be prepared by exhaustive electrolysis of water or as a byproduct in some fertilizer industries. Its physical properties are given. I will discuss that in the table here, which we had even though discussed in the last classes, in the last that we had done. And it is used for the preparations of other that is your deuterium compounds, and for that example we'll discuss Ca C2 plus 2D2O will give C2D2 plus CaOD2. Another is SO3 plus D2O will give D2SO4. Another is Al4 C3 plus 12 D2O, 3CD4 plus 4Al OD3. This is what we have for the heavy water, which is D2O. Now we discuss about the dihydrogen as a fuel. So for dihydrogen as a fuel, dihydrogen realizes large quantity of heat on a combustion. The data on energy released by combustions of fuel like dihydrogen, methane, LPG, etc. that are compared in terms of the same amount in mole and mass of volume that will be discussed in the next table in the form of it. And on the same way, from the table that will be clear that on the mass for the mass basis, a dihydrogen that can release more energy than petrol, about 3 times, and moreover the pollutants in combustions of dihydrogen will be less than a petrol, and the only pollutants that will be the oxides of dinitrogen, that is due to the presence of dinitrogen as impurity will with a dihydrogen. This is of course that can be minimized by injecting a small amount of water into a cylinder to lower the temperature so that the reaction between the dinitrogen and the dioxygen may not take place. However, the mass of the container in which dihydrogen will be kept must be taken into consideration, where a cylinder of compressed dihydrogen weighs about 30 times as much as a tank of petrol containing the same amount of energy, and also the dihydrogen gas is converted into liquid state by cooling to 20 K. This would require the expensive insulated tanks and tanks of metals alloy like NaNi3, NaNi5, Ti or TiH2, Mg or MgH2, etc. that are used for the storage of dihydrogen in small quantities. And these limitations have prompted researchers to search for alternative techniques to use dihydrogen in an efficient way. In the same way, where in this view the hydrogen economy is an alternative, and for the same the basic principles of hydrogen economy is the transportation of storage and energy in the form of liquid or gaseous dihydrogen. Advantages of hydrogen economy is that of the energy that is transmitted in the form of dihydrogen and not as electric power. It is a far it is for the first time in the history of India that a pilot project using dihydrogen as fuel was launched in October 2005 for running an automobile. Initially, 5% dihydrogen has been mixed in the CNG for use in four-wheeler vehicle, and the percentage of the dihydrogen would be gradually increased to reach the optimum level. Nowadays, it is also used as a fuel cells for generations of electric power, and it is expected that dihydrogen will be identified in the years to come for this usage as a common sources of energy as well. Now we talk about for the table that we have to discuss here, so we go for it. So the table about the energy released by combustion by combustion of various fuel in mole, mass and volume. So the table will be first for energy released in combustions in kg ray state. Energy released on combustion in kg state. So this is one. So the second column we have here is dihydrogen, which is in gaseous state. Another is dihydrogen in liquid state. The another is your LPG. Another we have is your CH4 gas, that is your methane gas. And the last we have octane in liquid state. Okay, now we go one by one. For energy released in the combustions in per mole. This is your dihydrogen in gaseous state is your 286. Dihydrogen in liquid is 285. LPG is that is your 2220. For methane it will be 880, and for octane in liquid state it is your 5511. Now for per gram, so dihydrogen in gaseous state it will be 143. This is 142, 50, 53 and 47. So another is for per liter. This is 12, 9968, 25,590. 35 and 34,006 here. 34,005. That is what we have here. Now here what we had done discuss about this hydrogen, where hydrogen is the lightest atom with only one electron. Loss of this electron that results in an elementary particles and the proton. Thus it is a unique in character, and it has a three isotopic, namely protium, deuterium, and of course tritium. Amongst the three, only tritium is a radioactive in spite of the resembles both with alkali metals and halogens. It occupies a separate positions in the periodic table because of its unique property. And hydrogen is the most abundant element in the universe in the free state, and it is almost not found in the Earth's atmosphere. However, in the combined state, it is the third most abundant element of the Earth's surface, where dihydrogen on the industrial scale is prepared by the water gas shift reaction from the petrochemicals, and it is obtained as a byproduct by the electrolysis of brine. And on the same way, when we talk about here in the detail for the same, so yes, the hydrogen bond dissociation enthalpy of dihydrogen, which is 435.88 kilojoule mole inverse, is the highest for the single bond between two atoms of any element, and that the property is made use of in the atomic hydrogen torch, which generates a temperature of near about 4000 Kelvin as an and is an ideal for welding of high melting metals. Though dihydrogen is rather inactive at room temperature because of very high negative dissociation enthalpy, it combines with almost all the elements under the appropriate conditions to form hydrides, and all the types of hydride that can be classified into the three categories, which is ionic or saline hydrides, or covalent or a molecular hydrides, and a metallic and a non-stoichiometric hydrides. Alkali metal hydrides are good reagent for preparing the other hydrides compound. Molecular hydrides examples B2H6, CH4, and H3H2O are of a great importance in day-to-day life, where metallic hydrides are useful for the ultra purifications of dihydrogen and as a dihydrogen storage media. Among the other chemical reactions of dihydrogen, the reducing reactions leading to the formations hydrogen halide, water, ammonia, methanol, vanaspati ghee, etc. are all the great importance. In metallurgical process, it is used to reduce metal oxides in a space program. It is used as a rocket fuel. In fact, it has a promising a potential for use as a non-polluting fuel of the near future, which is your hydrogen economy. And what is the most common and abundantly available substance? It is of a great chemical and biological significance. The ease with which water is transformed from liquid to solid and a gaseous state and to the gaseous state allow it to play a vital role in the biosphere, where the water molecule is highly polar in nature due to the bent structure. This property leads to the hydrogen bonding, which is a maximum in ice and least in water vapor. The polar that to act as an amphoteric The polar nature of the water makes it a very good solvent for ionic and a partially ionic compound, where to act as an amphoteric acid as well as a base substance and to form a hydrides of the different types, and its property to dissolve many salt, particularly in a large quantity, that makes it hard and hazardous for the industrial use. Both temporary and permanent hardness can be removed by the use of zeolite and synthetic ion exchanger, where heavy water, that is D2O, is another important compound which is manufactured by the electrolytic enrichment of the normal water, and it is essentially used as a moderate in a nuclear reactor. In the same way, where that is the hydrogen peroxide, which is H2O2, has an interesting non-polar structures and a widely that is used as industrial bleach and is a pharmaceuticals and pollutions control treatment in the industrial and the domestic influenza. Talking about the questions that will be dealing with, the questions and numericals we have. Justify the positions of hydrogen in a periodic table on the basis of the electronic configuration. Second question, where we had done many of the questions in the classes. Other than that, you have to deal with these questions, so that I told you. Second question, write the names of isotopes of hydrogen. What is the mass ratio of these isotopes? Third, why does the hydrogen occurs in the diatomic form rather than in the monoatomic form under normal condition? Next is, how can the productions of dihydrogen obtained from coal gasification and be increased? Next is to describe the bulk preparations of dihydrogen of electrolytic method, and what is the role of electrolyte in this process. The next is, you have to compare the following reaction, which is H2 in the form of gas plus MMOO, a solid in the presence of heat. You have to give the reaction. Another is CO in the form of gas plus H2 in the form of gas. In the presence of heat and catalysis, you have to give the resultant. Another is C3H8 gas plus 3H2O gas in the presence of heat and catalyst. You have to answer it. Zn solid plus NaOH aqueous in the presence of heat, where you have to give the reaction. Another question is to discuss the consequences of high enthalpy of hydrogen bond in terms of chemical reactivity of dihydrogen. Another is, what do you understand by electron deficient, electron precise, and electron rich compound of hydrogen? Provide justification with suitable example. Another is, what characteristics do you expect from an electron deficient hydrides, and that is with respect to its structures and chemical reactions. Another is, do you expect the carbon hydrides of the type CnH2n plus 2 to act as Lewis used to be used, or Lewis acid or base? Justify your answer. Another is, what do you understand by the term non-stoichiometric hydrides? Do you expect this type of hydrides to be formed by alkali metal? Justify your answer. Next is, how do you expect the metallic hydrides to be useful for hydrogen storage? Explain. Another is, how does the atomic hydrogen or oxyhydrogen torch functions for cutting and welding purposes? Another is, among NH3, H2O and HF, which would you expect to have the highest magnitude of hydrogen bonding and why? Another is, the saline hydrides are known to be react with water violently, producing your fire. That can CO2, a well-known extinguisher, be used in the case? Explain. The next we have here, there are many rest of the questions, we'll discuss that in the next coming class. So here we're gonna end up with this only. So first of all, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and even you can also enjoy the video as well. Other than this, we talk about it. So yes, we had done reasoning, which is your verbal reasoning and the non-verbal reasoning. In terms of quantitative aptitude, we had started with arithmetical ability, where we had done more than 17th topic, and we are dealing with continuing with the same. And now in terms of chemistry, yes, we had done your part 1 chemistry, where in that we had done your unit 1, which is your unit 1 which we had completed is your some basic concepts of chemistry. Unit 2 is your structures of atom. Unit 3 is your classifications of elements and periodicity of your properties, periodicity in properties. And unit 4 is your chemical bonding and molecular structure. Unit 5 is your states of matter. Unit 6 is thermodynamics. Unit 7 is your equilibrium. And unit 8, which we had covered up in part 2, that is your redox reaction. Unit 9 is your hydrogen. In redox reaction, we had even though cover up many of the topics related to it. Unit 10 is your S block element. Unit 11th is your P block element. And unit 12th is your organic chemistry, some basic principles and techniques. Unit 13 is hydrocarbons, and unit 14 is environmental chemistry. So here we're gonna end up with. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give your suggestion on a comment box. Thank you.